Okay, so today we're going to talk about statistical process control, aka quality control, where we answer one question. Are we going to approve the samples presented to us as quality products? We're going to find out right now. So, what is SPC? What is quality control? It's basically a statistical method that uses charts, means, ranges, standard deviations to assure quality control. So let's look at this comical example with some bowling scores. So going by week number, all these little dots represent means. So as you can see here, the team had a pretty good week. Here they didn't have much of a good week, but overall not that bad. I would probably do worse than them. So let us approach quality control with an example. So we have steel rebars. We have 50 samples. There's 10 steel rebars within each sample. We have sample means, sample ranges, and our standard deviations for each sample. So this little thing is an X double bar. Basically, it's the mean of means, so you add all these means together and you divide by 50, which is going to be K in some textbooks. Same thing with the range, same thing with the standard deviation. Here is our data. All of that is in megapascals, by the way. We are looking at tension, which is stress. So our big helper is going to be the X-bar chart, the very first one. You have an upper limit, a lower limit, calculated using this formula right here. And we have our mean, 405.6 megapascals. So just looking at the graph, here's our upper control, here's our lower control, and all these little data points seem to fit this graph perfectly, so we're not going to worry too much. But this point right here, that's a pretty good point. You have a high tensile strength steel rebar. Now we're going to look at our R chart, which is basically the X bar chart, but for ranges. Here's our mean of ranges. So this chart measures variability. The variability is pretty good, pretty high. Here we might have a problem. That's normally calibration. That's why you have to calibrate, recalibrate a machine after every 10 samples. Okay? And our final helper is right. The S chart, same thing, measures variability just like the other ones, but you're using a standard deviation. This one is more clear that the variability is not too high. This is probably the highest point. It's not even close to the upper control limit. So this chart works out. The X-bar chart also seems to work out, and so does the R chart. So all of our charts seem to be on. For this project, final decision, we approved the samples, and we can sign off on the project. Thank you.